HanselMinutes.com. It's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 169, recorded live Friday, June 19th, 2009. Support for Hansel Minutes is provided by Teller at RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.tellerik.com. And by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott talks about the art of unit testing with Roy Osherove.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting down today with Roy Osherove, the chief architect at TypeMock, and also the author of The Art of Unit Testing. Thanks, Roy, for chatting with me today.
Hi, nice to be here.
So you do a lot of unit testing. You are definitely a practitioner of correct unit testing. You've been doing this for years and years and years, and you work for a company now that enables unit testing.
Indeed.
You've written on the subject, and you've also been speaking here at the Norwegian Developers Conference on unit testing.
Yeah, it was a full day yesterday for me.
Yeah, you've been doing a lot of sessions. Now, you have been doing a thing lately on your blog that's pretty cool, where you're doing test reviews. You're doing code reviews of various different chunks of code. You actually did a review on Nerd Dinner.
Yes.
And you do it as a screencast, which I thought was cool. So you have a little picture of you in the corner, and you're walking through the code, and you're saying what's good and what's bad. What are the things that you've reviewed so far on your blog?
So far, I've only done 3 of these. I'm trying to find the time to do more. I think now I'll have some more free time. I did the review for Nerd Dinner. I did a review for the Unity, Microsoft Unity tests, and for the ASP.NET MVC unit test.
So you actually looked at the source code for MVC and the tests that we ship with it and reviewed those.
Exactly.
Okay. So let's talk about some of the things that were good or bad about any of those things. I know that there were some things in Nerd Dinner that were kind of sloppy, but there were also some things in MVC itself that you thought were pretty cool. So maybe we can talk a little bit about where to start. Because I'm thinking a lot of people who are listening to the show either are writing unit tests or want to, but they may not be following best practices or really any practices at all. Where do we start?
Well, it'd be hard for me to remember exactly all the little quirks that I saw in all the reviews, but there were things that just kept repeating themselves. First of all, in terms of quality, the ASP.NET MVC unit tests and the Unity source code tests were really good to watch. It was a pleasure to see that there were people inside Microsoft who really how would I say, embraced the whole idea of not just writing unit tests, but took into account the idea of quality unit tests. I think that the things that people usually repeat the most in terms of problems in tests is the readability of tests. That is, the naming conventions, the way the tests are organized, the code inside the tests. And usually, if you think about unit tests and what makes them good, there are 3 main pillars. The first one is trustworthiness. Are you able to run your test and trust the results? So if your test fails, are you okay with that it fails, or do you hear sentences in your job that say, for example, oh no, that's okay, it's supposed to fail, or that only fails every second time.
So is it failing for the right reason? Yeah. Is that what you're saying?
No, it might fail for the right reason or the wrong reason. The question is, do you trust the result? So if you have tests where you see a result, but you still go and debug your code just to make sure, or you see a result and you say, no, it's the wrong result, I know what's really happening, that means you don't trust your tests.
Okay.
And that usually creates a big problem, because at some point they're going to fail or pass for the wrong reason, and you're not going to trust that result.
Okay.
So you lose all the confidence or the time saving the tests are supposed to give you. The second one is maintainability. A lot of people write tests, but the maintenance cost of changing the test every time you change the code is too high. So a few months later, they stop maintaining the tests. And that leads to a big problem, because now they've also lost all the time of writing the test, and they don't get all the benefit of having them. They don't run them, they don't maintain them. And that's a very big issue. And there are simple workarounds for that kind of thing, like reusing code inside tests, refactoring. Now, readability is an issue because it usually leads to the other two. People write unreadable tests. Someone a test fails, someone tries to understand why it fails. They don't understand why. They start debugging. They may not understand the result, so they don't trust the result, or they don't maintain it because they don't understand what they should change, and it just deteriorates from there. But all those three pillars are just connected. You remove one, and the other two fail at some point.
Mm-hmm. The one that really resonated with me was the first one there on being able to trust it. I like that a lot. The idea that, so let me say, if I have a test and it fails and you just said like, well, it didn't really fail. It failed for this other reason, or this isn't expressing reality. I can't trust this. Does that mean that the test is testing too much or too little or the wrong thing? I mean, if I see a test that I can no longer trust, what is the next action that I should take so that I might trust that test in the future?
Well, there are several things that you can take action to prevent this problem. If you already have this problem, you really have to understand why it's there and then solve the core problem, not the symptom. This is just a symptom of some different problems. Mm-hmm. Things that lead to to test you can't trust. One of the core things is when you actually mix integration and unit tests together in the same project. So what happens is, because integration tests require configuration or that kind of stuff, they may not necessarily pass by default. You have to configure, maybe you have to have a database somewhere. Mm-hmm. So what happens is, in a real team, developers may get the latest version of all the source code and try to run all the tests. And some will pass, some will fail. Usually the integration test may not pass on the first time. So they get a mix of red and green results from the tests. And of course, the first sentence they hear is, that's okay, these tests are integration tests, they're supposed to fail because you didn't configure this and that and so on. So what happens is that they don't even bother to start configuring the test to make them pass. They just say, oh, it's an integration test. I have better things to do than make it pass. I'll just continue on. And what happens is they don't bother checking all the tests, whether they're integration related and all that stuff. They have better things to do. There is no, what I call a safe green zone. A piece of project where all the tests there should be green by default, no excuses. So the simplest thing is to manage integration separate from unit testing. Different project, different namespaces. So as a developer, I can get the latest version, right click on all the pieces of the project that only have unit tests, and they should all pass. And that way, I know that something has to be okay. If something there fails, I know that there has to be a problem. I trust these tests.
Okay.
So at least I have a piece of the test that I can trust.
See, this is good. You actually answered my next question, which was going to be, so often I see unit tests and integration tests mixed. What is the correct way to keep those things separate? I can actually think of some projects internally at Microsoft right now where the argument about unit testing versus integration testing is happening. We're all using unit testing tools for both unit testing and integration testing. And that blurs things for new people. And you saying you recommend different namespaces and even different assemblies.
Yeah, usually I use different projects for different assemblies, so that I can easily, in a command line, run only integration or both or just one of them. But seriously, just on the human factor, it's easier to run all the tests in a project than all the tests in a namespace or a folder. Mm-hmm. Just easier. So you want to make things easier for people, and they will do them. But you need to define what is the difference between integration and unit test. Some people will define a unit test as testing only the smallest piece of code. For example, just a method. I define it as something that runs only in memory, runs fast, does not touch any external state, and is repeatable. Whether it touches multiple classes or multiple methods, as far as I'm concerned, that's still a unit test. Some people will say, no, that's an integration test once you cross over the line to even test the code of another class. But as far as I'm concerned, as long as all the code under test is under your control, it's your code. It runs in memory and is repeatable and doesn't touch external states such as databases, file systems, or even statics. It could be considered a unit test.
Okay. I think you definitely said something that resonated with me there. You just said that as long as you're testing code that is under your control. Because when I think of a unit, and I've actually had these big arguments at previous jobs where we sit around and we argue about the definition of the word unit. Is it a method? Is it a few lines? Is it a one pass through a method? But I like the idea of kind of mentally drawing a circle, like a dotted line around some chunk of code, an arbitrary chunk of code. It could be one method, could be 10, but it is a logical unit of code. And what you just said that kind of crystallized for me was that, and all of that is under your control.
Yes.
Third-party libraries are mocked away. Things that I can't affect are not part of that unit of code that I'm testing.
And as far as we're talking about, faking things out, I don't like the word mocked away and so on.
Forgive me.
There has to be a difference between mocks and stubs, and people use the word mocking when they actually mean, no, I'm just creating a stub or I'm faking this out. And I think that we should stop using the mocking
let's take a moment actually, and let's take a moment from the conversation. Let's step aside, and why don't you explain to me mocks, fakes, and stubs?
Okay, so fakes are basically everything that looks like something, but it's fake because of your test. Okay. Now, depending on its usage, it's either a stub or a mock object. Okay. So categorically, they're all fakes. But a mock object is that thing that you might assert against to check if your test has passed. Okay. So it's a fake object that decides if your test has passed or not. A stub is just something that helps your test run.
Okay, so a stub is something that I would write just to get through, just to get it to work, get it to compile.
To get it to actually run.
To get it to actually run.
Yes.
But a mock actually has some behavior that I might assert against.
A mock is something that I will assert against.
Okay, you actually will assert
it might have behavior and I'm not asserting against it, then it's a stub. Okay, I might have multiple stubs inside a test, but I will only have one mock object.
I see. So stubs,
I'm only testing one thing.
A stub might have behavior, but it may not be a behavior that I am going to assert against. It's just behavior that I needed to get the thing to work.
It mimics the system as far as I'm concerned. Now, in the book XUnit Test Patterns, there are more definitions of these kinds of fake objects. There's test spy, there's test double and all that kind of stuff. And they all are just subcategories of that fake object that I just talked about. But if you're just getting started, there is no need to learn about all these different things. You just need to know that I have these fake objects. And if I look at the end of the test and the assert is against one of those fake objects, then that fake object is a mock object. Everything else is a stub. Okay,
good. So then for the new people who aren't necessarily into unit testing that are learning about this, let's take what we just talked about and let's bring it back and let's imagine two tests that are one is a unit test of something and one is an integration test of the same thing. Let's say that we're talking to the database. So I'm going to go and test get customer. I've got the get customer unit test. I've got the get customer integration test. Is that a reasonable scenario?
Well, actually, database-related tests are a special case as far as I'm concerned, because if you're testing a data access layer, I would not recommend writing a unit test for that. I would actually recommend to test it with a real database, because data access layer has very thin, if any, logic whatsoever. It usually just creates either queries and sends them to the database, and then the database contains another piece of that same logic.
I see.
You want to test the logic inside the database, whether it's triggers, stored procedures, table relations. That's something that usually you don't test unless you invoke it through the data layer.
I see.
That's all the same unit as far as I'm concerned. So it has to be an integration test.
So maybe then a more appropriate thing would be to raise the layer of abstraction a bit to a service layer.
An example that I usually use is a very simple one where, let's say that you have this class called storage, and this class takes an object with properties, and given some property that's true on the object, the requirement is that the class calls some sort of logger. Okay, logs to the system, or maybe it's a web service. Okay, so our decision is, what do we do with that logger? The logger is considered a dependency because it talks to the external system.
Okay, so I'm trying to test storage, not the logger. Is that correct?
Well, what you're trying to test is the requirement that it calls the logger. Given that a property on the object being sent is true. So if the storage is being sent with an object too large, it says to the log, I got an object too large. Okay. So you will see in the log file later, object with this size was sent in.
Okay, so to make sure that I understand, because I don't want to be incorrect, we're trying to the unit of work we are testing is that our object called the logger, not that logging occurred or that things got written to disk, but that our object's behavior, its expected behavior, call the logger if it's too large, etc.
Yeah, well, that's a difference between a unit test and integration test in this case. If I was writing an integration test, I would actually test that after calling the save method on the storage, I would test that there is actually a file on the system with specific text inside it.
Excellent example.
And if I was testing it as a unit test, I would test the interaction between the storage and the logger without having a real logger in the system at all.
So would that mean that between these two theoretical tests, the unit test and the integration test, that a large chunk of the code would be the same? It's the assertions that are going to be different?
The assertion will probably be on a different object. Yes. One of them will be on a file system, and you will also have to clean up after yourself in the test to clean up the file that was generated.
Right.
And on the unit test, you would have to create some sort of fake logger, initialize the storage with that fake logger, and then assert on that fake logger that it was indeed called with the right parameters. And so you would have to somehow save that information on that method call. And that's where isolation frameworks, or what usually people call mocking frameworks, come in, where they allow you to create those fake objects dynamically. So in that case, that fake object would indeed be a mock object.
Okay. Do you know how to make the possible out of the impossible? Well, the .NET ninjas at Telerik do. They just released a huge pack of web controls all built on top of ASP.NET Ajax that'll help you build impossibly fast and interactive applications in no time at all. They've made the impossible possible in desktop development. If you think you can't have a carousel component in WinForms, well, you can. Their Windows Forms suite features a super powerful grid view control and 32 other crazy desktop components that'll give you dazzling WPF-like features, but in WinForms. They do the same thing in reporting solutions with a new design surface like nothing else. Looks just like graph paper. Gives you advanced page layout capabilities. Makes it feel more like a graphic design software than a reporting solution. Go check them out at Telerik.com and be a .NET Ninja. And thanks for listening. It's good that you have these strong opinions about how we call things, because really in object-oriented systems and in programming in general, what you name something colors the way you perceive it and the way you start thinking about it. So, I've got this word mock stuck in my head and I'm using it and it's coloring my perceptions.
Yeah.
You're saying rather than mock framework, like the product that your company makes is an isolation framework. So you're picking a much more descriptive word.
Well, I think all the other frameworks are isolation framework as well. They're not mocking framework, because if they were mocking frameworks, all they would generate for you is mock objects.
I see.
But they also generate for you stubs.
I see.
So that confuses. If you know the difference, that confuses you. If you don't know the difference, you don't know enough anyway. Okay. So I don't want people to be confused. The whole idea of these frameworks is to help you easily isolate a unit from the unit it depends upon. So it's an isolation framework.
Okay. Excellent. And then what kind of, other than knowing, like you're saying, knowing intuitively to smell whether the code is good or not, whether the test is correct, what are some of the things to watch for? You had mentioned naming conventions, whether or not something was truly isolated or not.
Well, there are smells that are symptoms when you run tests. For example, tests have to be isolated from each other as well. They should have no repercussions on other tests. So if you have a test that if it's run before another one, so if tests are run in a specific order, they fail, but if they run in another order, they pass.
That's a very common smell.
That's a very common smell. That usually means that you probably have an integration test on your hands anyway, and that you're not cleaning up after your test. So they're using the same shared state, and they're not rolling back after changing it. And that means they're not isolated. But a very common mistake which people don't notice is that they actually write tests that invoke other tests. And the reason they usually do that is to actually reuse code. They do that to reuse code for a good reason, because they don't want to repeat the same code in tests.
Okay.
But they do it badly because that other test runs, but the setup method for that other test doesn't run. The teardown method for that other test doesn't run. And there's another assert running there. So they're testing two things at the same time, but the conditions are unknown. So there are two ways to screw that up. Either not clean up after yourself or invoke other tests. But there are simpler things. There's the notion of testing multiple things. If you have multiple asserts in your test, 90% of the time, it means you're testing more than one thing. And if you're testing more than one thing in a test, it will be hard to give it a good name. It will be, if it fails, it means that either multiple things fails, or it will be harder to find what it is that failed. An assert, when it fails, throws an exception. So every assert after it will never run. So you don't know the full picture. Okay. That's why you usually just one assert per test.
Which is interesting because that was the next question I was going to ask you, is that I find when I'm writing tests, I end up doing a lot of copy pasting, and I get a lot of tests that have like 4 or 5 lines that are repeated over and over again. And I'm not sure if I should extract method and pull those out. And then I ask myself, well, do I need 1 assert per test or 5 or 6? I say, well, while I'm here, I've got these objects. Why don't I go and assert these 7 or 8 different things? And you just kind of answered my question. You think 1 assert per test?
Well, it depends what it is you're testing. If you remember, the idea is that you're testing one logical thing.
Okay.
So, 1 assert per test usually is enough. The only time where it's not enough is when you're testing different properties on the same object as the same logical result.
Okay.
So I'm asserting that I'm getting back an object that looks like this and this and this. So that's where you would have maybe multiple asserts, but they're all part of the same logical check.
So it's okay to say, make sure that customer count is greater than 0 and less than 100. I don't have to go and make another whole test just because I want to check 2 attributes of the same thing.
If you're getting back an object, if you can create an expected object and then equal between them, that's 1 assert. That's testing multiple things at the same time. If you can do that kind of thing, it means you're testing one thing.
Okay.
Okay. But usually, people are testing more than one thing without realizing it.
Now, one of the things that, when you did the Nerd Dinner test review that we didn't do a good job on was the naming. And I know that you feel strongly about naming tests correctly. Why is that so important?
Well, naming tests, there are 2 audiences for the test names. First of all, if we talk about the beginner crowd that just gets started writing unit tests, the pattern that I use for test has 3 parts that are very, how would I say, they're very strict. You're forced to write the name of the method under test, the scenario in which you're testing it. So, given, database that contains 2 rows, calling a method X, and then you have the third part, which is the expected behavior. Then X should throw an exception.
Okay. So you're saying that your method name is saying, given this.
Yeah, but not in that order. It usually means just the name of the method, behavior, and scenario, expected behavior. And then there are underscores between those. And the underscores are there to tell you that there are 3 parts. So if you forget one, you know about it.
So you don't like putting underscores between every word. You put them between the parts.
Yes.
So can you give me an example of a couple of?
Let's talk about the test I just explained earlier. So if I was testing class storage and had a method save, then the test would be called save underscore object too large underscore calls logger. Writes to log or something like that. Okay. So it's almost like a sentence, but it's structured enough so that beginners will always remember to write all these parts. Now, as they get comfortable, they can create their own naming convention. But these 3 parts are important because now we're talking about the other audience, and that's the person who reads the test that you wrote. And that's the person that didn't write that test, and they need to understand why it's failing and why it's passing. Now, if the test name does not contain all these 3 parts, then they have to go into the test and understand and go through the code, and that takes time. Now, usually when you have, let's say, 1,000 tests running and 5 of them fail, the only thing you see in the test runner is the test names. You don't see comments. You don't see anything else. So if I can, just by looking at the test names at the test runner, figure out what is the problem and go directly to production code, I've just saved a lot of time. And I know exactly what is the problem in terms of the requirement and the problematic behavior. Now, BDD style naming and all that stuff, they all contain those same 3 parts.
Right.
They just contain them in different structures.
That's interesting that you say that because I've seen people say, well, you should name your tests a certain way. You should give them a structure because when they are alphabetized in a long list, it makes things implicitly grouped, which is good. You're saying put all 3 bits of information in the method because that's what most test runners shows, but like you just said, BDD or, behavior-driven design, people often say, well, I don't want those 3 pieces in my method. I'm going to put part in my namespace, part in my class, and part in my method. But then you have to go and change the output columns of your test runner to show you those bits of information. It's not really in one place.
Well, sometimes people will actually go to a different structure where there is a class per a specific method under test, or a class per specific behavior under test. And the class is actually the context. The class name could be the context. And the setup of the class is the setup of all the possible test cases. And then each test case inside the class is just a different assert.
Okay.
And that makes sense when you're testing multiple results of the same action. It makes less sense when you have very simple tests where you just, given this, I'm getting back that.
Right.
You can do both styles of tests. I'm not a big proponent of the BDD way because I think beginners find it much harder to get started with.
Yeah.
They find it easier to read, but to get started writing that kind of stuff is kind of hard for them. And for writing tests, the simple way is just a way to ramp up. And after that, if that makes sense, going to a different style of writing tests, definitely go ahead and do that.
Now, is that what they call the context specification style of test?
Well, there is a context specification, and there is there are a whole bunch of different categories. I don't think that I quite understand all the differences between them. I never really got into that whole world. I'm still trying to get in there. I'm still trying to find more value in that style of writing than in my current style. And I've been looking at that for maybe 6 months now. And I still haven't found enough for me to switch.
Not enough, something compelling enough to make you change.
It is nice. There are some very elegant solutions there, but personally, I really like the really, really simplicity of the way that I write tests today. Everyone gets that. I can teach that. Everyone does that very easily. It's just a great way to have greater adoption. And adoption, I think, is something that we should all be striving for. And the more we complex things, the less people will adopt these great practices.
Now, how does this scale? You had made the comment of when you have thousands of tests. What does the structure look like of my solution? Let's say I've got some, fairly good sized system and I've got 1,000 tests. Do I have a few hundred per project? Do I have many assemblies? You'd said we might have assemblies for unit tests and assemblies for integration tests. Where are my partitions? How do I chop this thing up?
I usually just naming conventions of the project. So you would have project X or project, and then you would have project X dot tests, and then you have project X dot integration tests. So you'd have max of threes. So and that way, if you look at the solution tree, you would see them next to each other. Some people like to group them by folders or group them by namespace that starts with tests and then the same name of the project.
Okay.
So it's all a matter of just being consistent. As long as it's easier to find, given a name of a project, it's easier to find all the tests for it. I'm okay with that.
Okay. So then within a testing assembly itself, let's say that I've got some assembly that's got many, many classes. When do I make a new class within my test assembly?
Well, I usually start, especially at the beginner level, with the class under test. I would have a class for each class under test. I would have a test class.
Okay, so you're still 1-to-1. So one assembly, one test assembly, one test class.
I start with 1-to-1, and I start with the mapping of if I test a method, I start with a test method.
Okay.
But at some point, you might realize that you are writing a lot of tests just for one method, and you would separate the class for just one method's test. Or you would go further and you say, I have a class for a specific scenario for a product, and then it no longer maps to a specific class. It just maps to specific scenarios on the whole product, and then it checks multiple classes at the same time. It's all a matter of what you're comfortable with, but the easiest one is just mapping 1-to-1 in the beginning.
Now, I may be inappropriately obsessed with cyclomatic complexity, but typically when I have a class, a method rather, that has a couple of inputs, I always try to have a reasonable amount of code coverage. I don't necessarily go for 90% plus or try to overly focus on that metric, but I usually just can't stop myself from writing lots of negative tests. I'm always doing this. I don't know why it is, if it's correct or if it's just me and I'm wrong. I'm always trying to throw inappropriate inputs into my methods.
Because you're a really negative guy.
I'm truly a negative person. Very, very negative. A lot of black t-shirts. Is that right? I mean, what's the ratio of negative tests to positive tests? I'm always trying to break stuff, and I find by throwing inputs at my methods that it lets me understand more, kind of like figuring out the negative space lets you understand the positive space.
The question is, when do you write the test? Do you write it before or after the method?
That's an interesting point. So that's funny. You've actually caught me in something. I think I write the positive tests first, and that helps me design it. Mm-hmm. And then once I've got it mostly working, I write a bunch of negative tests. I'm not sure if that's right, but that's what I do.
Well, yeah, that's close to what I do. If I write tests in a test first manner, and that's what I usually do, mm-hmm. I will drive real functionality. I will never start with an invalid value because you don't provide real value. And you can go to your boss and say, "Hey, you know what this doesn't handle?" This totally does not. It handles invalid values amazing. No, It doesn't do anything, but you can send -1. It'd be amazing.
Exactly.
So you have to start with real value, and as you get real value that you can actually demo, you can start throwing in invalid. Especially with some types of work, you can dive really deep into a bunch of invalid values. Mm-hmm. At some point, you might want to start doing range testing, which is just getting all the values from some Excel file, just throwing it at the method and seeing what happens. Mm-hmm. But I would only do that kind of thing, or maybe throwing in random values after I've felt comfortable with the method. Mm-hmm. So I will tell people you should stop writing tests for a method when you feel comfortable about it. So they say, what does that mean? I say, okay, remember when you didn't write tests? When would you have stopped writing or debugging the method? When you felt okay about it, right?
Right.
You're going to get to that feeling after you have enough tests. When will you have enough tests? When you feel comfortable about it.
So it really is about that, whether you have that sense of safety, because the test is supposed to provide a sense of comfort.
It is. It's about people. And if people don't trust the tests, either they need to write more tests or something in the test is wrong.
That brings us full circle to your first pillar, which, the one that really resonated with me was that I need to trust these tests.
Yes.
Are they trusting? Now, what were the other two pillars again?
There is maintainability and readability.
Okay. So, readability makes sense to me. I can understand how unreadable tests would be a problem. I know that there are people, like Jim Newkirk and Brad Wilson that don't feel that setup and teardown is an important part of tests. Having a class start up, prepare some things, get some context ready, have a bunch of tests run, and then have a teardown. Do you feel strongly one way or the other?
I think it's a bit of a nitpicking. I think that beginners shouldn't care about this kind of nitpicking. Mm-hmm. They should start with this because it's very simple. And at some point, if they see any pain points, they can start not using setup and teardown. It can hurt readability if you abuse setup and teardown methods. Mm-hmm. But here's a little tip. If you use teardown methods, usually a sign you're doing integration testing. Just so you know, I almost never use teardown methods because if you have to clean up after yourself, it means you're probably doing integration testing. Setup is very, very common, but people abuse it because setup should only be used for creating things that all the tests in that specific class use. So if I look at the setup and I see what's created there, calculator, okay, then I know it's used all over. If I instantiate there things that are only used in some of the tests in the class, mm-hmm. then that creates confusion because now I have to go to some tests and understand which tests use it, which tests don't, and understand what context it's used, when it's relevant, and so on. And that does create confusion. So setup can be abused, and I can see their point. Mm-hmm. To the point where I don't have a problem if people will never use setup and only use factory methods from within the tests. But as a learning tool, as a step to getting to reuse code in test, a mm-hmm. setup method is great.
I think you made an interesting point, though, that if you find yourself using a setup method and it's really just for object creation, then maybe you need to be thinking about how you create your objects, in a factory method inside of the test would be easier. Because I find a lot of people abusing setup in the sense that they're saving too much state in their test class, and then suddenly you'll get yourself into side effects where your tests have to run in a certain order.
Well, not if they all run the same setup.
So there are test class level setups, right? There's the setup that runs per method and then the ones that run per class in some frameworks like NUnit, right?
All the frameworks have that.
They all have that?
Yeah.
So is that something that someone should think about, the idea?
I've almost never had to use a class level setup. If I do, it's usually integration test. Okay. So the only time you don't have a smell in your tests is you only use setup.
Okay. That's
then I can tell you if you're using integration unit. If you're doing test class level setup, probably means either using statics in your application or using integration, because you have to clean up or set up some sort of state outside or generate some code or whatever. You are creating some horrible, hard to create state. Otherwise, you would have done it at each test.
So that's a really good rule of thumb, though. I like that. If you're using a teardown, you're probably doing an integration test. If you're using a class level setup, then you probably got some statics in your application and you've got bigger problems. Well, thanks a lot, Roy. The product is TypeMock Isolator, and the book is The Art of Unit Testing.
Yes.
All right. Well, thanks so much, Roy Osherove, for talking to me today. This has been another episode of Hansel Minutes, and we'll see you again next week.